Today I'm going to talk to you about two separate things. First of all, I'm going to talk to you about modern software development, and a bit later on I'm going to talk to you about the scaled agile framework in Jira, using that, and how to scale your infrastructure and operations in the larger publics. So first of all, a little introduction is in place. Who am I? I'm a computer and software enthusiast. I've been fiddling around with computers since I was a little kid. I think I started when I was 3 or something. So back with Amiga 500 and moved on from there. Never really stopped. And when it became time for me to kind of figure out what I'm going to do with my life, the option for me was quite clear. And I started studying computer science. And through that, I, of course, got a job in the business and started doing all sorts of software development related things to begin with. I do like gaming, computers, everything to do with that, some climbing and stuff. What especially has struck me is software quality, how to tool around that so that you can produce quality software, and how you can make that process as efficient as possible. And in my working life, I've been doing all sorts of things. So I'm kind of a jack of all trades, if you will. I've been doing consulting and systems work and software development and of course the occasional sales here and there. So I'm kind of trying to get a pretty holistic view of software development and the business as a whole, so to speak. So, why do we need Devops? So this is basically the introduction, the path to what's happening today. So everybody kind of claims that they are agile, and everybody kind of claims that they are doing DevOps, but only a few actually know what it means, and only a few are actually doing it. So it's kind of like in the recess of high school when people are talking about how they're totally doing DevOps, but they're not really doing it. So it all starts with requirements. So when these more sophisticated computer systems started forming, it meant that you had to gather more and more requirements to have the software meet the demands that it faces. So out of this necessity, Waterfall was born. And on the right side, you can see Margaret Hamilton with the Apollo space missions code on punch cards. So that's kind of to give you a context of kind of what we are coming from. But as you all understand, that's not something that we can still do today the way they did it back then. So we have to evolve in this business and how we do things. Waterfall itself is a very rigid system. It relies on very systematic gathering of requirements and making kind of a perfect specification out of that. Well, this also means that because you have to define everything beforehand and then implement it, it means that you have very long these development and release cycles. So that's also not okay these days. And who here has ever done a perfect specification of a computer system? Hands up. Yeah, that's what I kind of thought. So it kind of has this built-in assumption of you have to know everything beforehand, and no one ever really does. Even though they think they do, they don't. So this kind of insight into what is being done is acquired during the development. And this, of course, then leads to failed projects. Incorrect or incomplete specifications. The end result is made to kind of match the contract that was made in the beginning. And if the contract itself is wrong, then the software that comes out doesn't really match what has been the actual need. It might match what's been agreed, but it doesn't match the actual need. So this basically boils down to monolithic projects that don't really come out on time. However, even today there might be some applications that kind of benefit for this more rigid approach. For example, if you are doing some kind of rockets or something like that, of course, you have to agree beforehand on what's being done. The specification has to be pretty exact so that different parts of the organization can do different things at the same time and still kind of meet the same goal. Think about like hardware and software developers. So after this, computers started gaining popularity, of course, even more so in the beginning of 2000. With the arrival of PCs and later on smartphones, of course. This also means that the demand for software increases a lot. Waterfall method doesn't really cut it here anymore. So we need a faster, more productive way of going at it. So the Agile Manifesto was born in 2001 and briefly basically emphasizes these things, so individuals and interactions, working software, customer collaboration, and responding to change. Well, those are all good things, but then again, if you think about, for example, processes and tools here, that's a very integral part of DevOps, and I think this is kind of overdoing it. And this is only a part of the solution. So working in this agile way basically allows you to have a non-rigid way of gathering requirements, and this means that the requirements can actually change over time. So as you gain this insight during the development of software, you can actually change your plan according to that insight you have gained. So this means that the development teams can actually react to these changes, and the customers as well, because they will understand during the development that, okay, this thing that we asked for isn't quite what we actually need, so could we do it this way? And when you're working in iterations and kind of releasing small batches at a time, then yeah, sure, you can. So yeah, where the waterfall aimed to kind of create this perfect contract and fulfill that, the agile method then itself aims at like satisfying the actual customer needs. So this is a step for the better. And being able to adapt in this way is of course essential, but this doesn't really by itself cut it in 2018 anymore. So the problems and solutions here with Waterfall and Agile. Well, with Waterfall you have this very, very rigid contract of what you're trying to fulfill. Whereas in Agile, you're kind of working in these iterations and adding to the final product a bit by bit, which means that you can actually change. Waterfall projects are often quite contract-based, so they have a set price, set requirements, whereas Agile way of doing things then more commonly is about billing the amount of time you have spent on it and not so much the fixed price. With Waterfall, when you're developing things, it often means that you only start testing things after they're ready, while you should actually be testing things while they are being done. Like all the time, when you make small additions, you should be testing them. With Waterfall, you cannot really see into the process what's happening. But then again, with Agile, you can actually see the status both as a member of the project and as the customer. So you can see what's actually going on at least every few weeks or so when you go on to a new sprint. The changes that are needed, they can't be accounted for during development in Waterfall, whereas in Agile you can. So this is kind of repeating the same message all over again. So be able to react to whatever it is that you need to react to. So okay, now you're working in Agile. What happens next? Well, the Agile way promises a lot of things, but it ultimately lacks the tools of delivering on these promises. So we need something more. Second of all, you're Agile, or are you really? I mean, in bigger organizations, especially, the development teams themselves might work in sprints and might work in a very agile way, but the organization as a whole does not. So usually when we talk about business and talk about how the requirements come from business and end up being stories or epics or whatever, that process itself is not agile at all. So it's very waterfallish. And I'm going to talk a bit about that in my other presentation. The pace of changes it has been growing all the time and it's still accelerating. So how do we respond to these ever-increasing demands for quality and for the pace of your own releases? Well, this basically boils down to moving on to DevOps. And the thing about DevOps is that it's not really binary. You're not either doing DevOps or not doing DevOps. You can start doing DevOps bit by bit. You can start your transformation, adding a little by little all kinds of tools, automation, the DevOps way of working, breaking silos, and so forth. So DevOps itself is not a replacement for Agile, but it instead builds on top of that. So what we have in Agile and DevOps is that in Agile the delivery of new features is often delayed, but because in DevOps we use these tools to automate things and test new features as they are being developed and completed, this doesn't happen as much when you're using DevOps methods. Completed software components are not compatible with each other, but once again, because we automate these processes, we automate the testing, we can kind of test them on the fly even before they are ready. The quality of the product is not ensured properly prior to the release. Well, once again, because we automate all the testing, we can do the testing on the fly as we are developing. So that means that we don't have to kind of organize a huge testing effort once everything is complete and then panic when it doesn't work, because we can see those hindrances beforehand and we can react to that during the development process instead of after. New features break old functions. Same story here. We are testing all the time. Budget goals and deadlines are missed. Well, yeah, it's not like DevOps is immune to that. But then again, when you have these metrics that you can pull out of this toolchain that you have, you can actually predict a lot better on where you're going and are you going to hit your goal that you need to hit. And of course, when you are maybe even doing continuous deployment, continuous integration, it means that you can actually release stuff as soon as you're done with them. So having a deadline where you have to kind of deploy a new system with 100 new features is not really an issue in DevOps, because you can just deploy a new feature on Monday and then another on Thursday, then some more on next week. And kind of the core concept here is that the developer teams and the IT operations people are not cooperating. And that's what the term comes from. Development operation, DevOps. So yeah, because we have these automated pipelines, the goals kind of become unified because the responsibility for software to work becomes end-to-end instead of just having a situation where it works on my machine and then you compile it and give the binaries to operations and say deploy it. Well, if you deploy automatically and it works in each phase of the pipeline, then that's no longer a problem because it doesn't happen. So basically, we're talking about making things a lot easier also because we're automating things. So in a classical way of developing, it might be really troublesome to get environments and get them on time and get them with the right configuration. But when you are trying to move on to DevOps and you start virtualizing things, you can have all of that infrastructure code as automated scripts in your repository. So you might have Puppet stuff, you might have Ansible, you might have Chef or things like that. So you can kind of always have a documented state of what your environment is in, but also have it in your repository so you can repeat it. You can pull up another virtual machine with the identical configuration. So you no longer have your development environment, your testing environment, your staging environment, and your production environment that are supposed to be similar, but end up having different versions of Java installed or end up having different operating systems. Because when you're doing it from the kind of same template, they're all virtually indistinguishable indistinguishable from each other. Okay, dependence on one supplier, narrow skills palette involved and forces unnecessary compromises. So this is just something that a lot of the older, bigger consulting companies have been kind of leveraging for years. But with this kind of having everything as code and having everything, all of your assets in your tools and having the development itself be very modular. This means that you are no longer trapped with one supplier, but you can actually just change your supplier if you need to. The completeness of customer requirements is difficult to monitor. Well, yeah, that's the old story with the waterfall and also partly with the agile methods. But here with DevOps, the customer requirements can be centralized into one place. So you have your systems where you can monitor your work and track your work, and then you have your systems where you have your documentation. And on top of that, all of the other systems such as binary storage and repositories where you actually have, even though it's just code and even though it's infrastructure code, it's also kind of documentation for the system itself. Human errors in quality assurance lead to uneven quality. This is very much what's still happening today. A lot of the kind of bigger companies, older companies, are still using a lot of manual testers. And manual testing is not only prone to human error, but also pretty expensive. So when you start investing in test automation and then start running it all the time, it means that your tests have always, they repeat the very same steps each and every time. So if you have something covered as a regression test, it's always covered. Once it breaks again, you immediately notice it before it even ends into the staging environment or the production. So people who work on product development are frustrated by repetitive work tasks. Well, I'm sure all of you are very aware of that. But once you start automating these little things, it kind of frees up time for yourself to work more productive. So basically, this is what it boils down to. Waterfall is all about methodical approach. Agile is all about cooperation and incrementality. And then DevOps is all about the automation, virtualization, visibility, and as a tooling enthusiast, I'd definitely say it's generally tooling, all the tools that you need. And the cooperation is, in my opinion, very much also a core part of DevOps. I mean, that's literally in the term DevOps. That's what it means. So, why DevOps? Just to reiterate. Now, this is why. These figures are from CA Technologies TechSites report and the Puppet Labs State of DevOps report from 2013. The new State of DevOps report actually just came out a few weeks ago. You should check it out if you didn't already. But as you can see, this research points out that you actually have smaller development and maintenance costs. You have fewer failures, and I think that's pretty huge, that you have a twofold increase in the chance of a successful product release. So what this basically means is, because you are doing this automated, and because you are preferably doing continuous deployment or continuous delivery, it means that you can release stuff in smaller batches and it's automatically tested. So when you release something into production, it's a small batch. It means that the risk of there being something wrong with it, especially after it's been tested, is pretty small. And if you do get like a catastrophic failure in your production environment, it's a lot easier to track down what caused it, because the change that has been applied to the system is actually a lot smaller than it would be if you were to deploy 6 months worth of code. All of this automation basically means that you have 30 times faster release. So deployments from 30 times more frequently, it means that you are deploying 8,000 times faster. So was it Thomas Alibaba that you talked with? where you ask them what's their time to market.
Yeah, I remember.
Yeah.
Yeah.
Yeah. So what they said is that their time to market is 11 days. And Tuomas thought about it for a while and said that, well, that's not awfully fast. I mean, what are you doing in 11 days? Well, they're coming up with the concept, they are creating the tickets, they are developing the software and releasing it in 11 days. I mean, there are a lot of organizations that are actually developing software for half a year, and deploying once or twice. Imagine deploying multiple times a day. That's what you can do when you have actually everything tested automatically. So, in the end, you gotta go fast, right? So, what this is all about basically is that the quality is built in, because it's a prerequisite basically for having the whole process there to have everything tested. So the quality has to be built in. Well, of course, with testing there's the cost part. So the manual testing is very slow, it's very costly, and it's prone to errors. But after having the initial investment into test automation, it means that the tests can be run all the time. And only cost there after they've been developed is the infrastructure resources that they use up when you run the tests. And that's not a lot, especially if you're using on-demand resources. Say you're using AWS or Azure and you only spin up an instance when you have to run those tests, and then you spin it down afterwards. So it only costs something like a few cents to run the tests. Speed, of course. You can actually patch a bug in a matter of hours or deliver a feature in a matter of days or weeks. And that has a huge impact on customer satisfaction. So imagine there are two competing products which have bugs in them. And the other product is being patched daily. The bugs are being smoothed out, the features are being added. And the other product releases only once every quarter. People move to the other product very easily because they don't want to be using bugged software. I mean, that might have been the case a decade ago, that people using, 2 decades, using things like Windows 98 and Internet Explorer and saying that, okay, this is just what computers do. Software just is buggy, we just have to live with it. So this is how it works. But not anymore, not in 2018. Software that doesn't work is not acceptable by consumers, not anymore. And of course, the measurement and traceability side of it. So basically, when you have all of these tools, it means that you can extract information from all of them. You can cross-reference that data, and you can visualize it. So you have a lot better view of what's going on and what's going to happen, perhaps. This also allows you to figure out the bottlenecks in your process, and then concentrate your resources where they're needed. So if you, for example, have developers that are working lightning fast, they're pushing stuff out all the time, but your bottleneck is in having one manual tester. So you can't release, you can't deploy, because all of this stuff has to be tested by one person, and you kind of have to think about, could I utilize my resources better here? Could I, for example, start automating these tests so that we could actually release the stuff that we have already developed? So, fast and frequent releases also mean that you have less dead code. And dead code here means that basically when someone starts coding something, that's an investment. That's an investment of time, that's an investment of money. And as long as you don't release that code, it's dead weight. It doesn't produce anything back. So the faster you get it out, the faster it starts paying back for itself. Missed opportunities. If you are too slow, your market share might be gone. There might be changes in legislation. There might be just new players who grab up what you already wanted to grab. But in the end, what really matters is who gets there first. and who can actually provide the kind of quality to keep that market share as well. And this boils down to these bite-sized releases. So when you release fast, you release small, you reduce the risk of these severe problems and make the problems in the end easier to fix. And like I said before, the quality is really built in because the requirement of having automated tests and running them all the time, every single commit, every single push, you have to run those tests. So this is the DevOps maturity model we've been using to kind of evaluate companies on where they are at in their DevOps transformation. I won't go through it here in detail, but you can kind of take a look at it maybe later on. I can share these slides. You can check out where do you think that you are in this maturity model. So there are quite a few moving parts. So where do I actually start? Well, let's go back to the start. What is DevOps actually? What is it? Well, it's this software development method or even an ideology that relies on these three things: heavy automation, virtualization, and smart tool choices. But it also relies on a certain kind of culture in an organization, which means that you have to break down silos and make people work together. And what really kicks this off usually is tooling. It might sound kind of funny, but once you have these processes defined out on how to, for example, take stuff to production, it immediately decreases the friction between developers and operations, because operations no longer has to stay up all night because of a rotten build that came up from the development side. So how do you start going faster? Very first step is to get the infrastructure up and running, meaning all of the tools, get the tooling correct. You could start onboarding newer projects where the technical depth isn't yet piled up. So if you have a 30-year-old mainframe project, that's not a very good place to start going very, very DevOpsy, because, well, try to automate all of those tests and try to automate the deployment of an old mainframe. It's not exactly easy. Yep. Then invest into this testing side and implement your continuous integration pipeline. And then you can start moving forward by increasing your test coverage and implement the continuous delivery or even continuous deployment. And this is kind of what we, in the end, really want to do. So you have requirements that are flowing in an even organized way from the business side. All of it going through software development and the CI/CD pipeline. So development leading to testing, leading to integration, and finally acceptance testing. And of course, all of these things are always stored in a correct manner. So you have your source code in your repositories, you have your built artifacts in your binary storage, you have your documentation where it's supposed to be, you have your environment, either infrastructure as code or saved virtual machine images in your binary storage. Preferably both. But what this means then is that once something like this is implemented, it means that your work is kind of freely flowing through the system, and then you can start to see patterns on where things are slower, and then start to focus your resources there. And to kickstart this transformation, you could have this ready-made turnkey solution, which is our DevOps platform. I won't talk about it anymore. I will give the stage to Tuomas, who can tell you a bit more about this DevOps platform. Unless you have questions first.
You can go ahead with the questions. I'll set up my PC there on Mac.
Any questions? None? So how many of you actually have continuous integration set up in your software development environment? So yeah, about half, yeah. But there's of course a lot of things that you can move on with from there. So kind of moving on to the deployment itself. So not only integration, but actually deploying it somewhere, and then tracking that all of the process. So how fast is it going? What's your time to market? How fast are your ideas turning into features that are being released? And what you can do to kind of make that even faster. But if there's no questions, then thank you all for coming here.
I've got a question for you.
Yeah.
This automated testing thing and the fact that the developers need to be developing tests at the same time with developing their code, that effectively means they'll be doing twice the work. Meanwhile, the pressure from the outside just keeps building and building, and you need to keep getting things done faster and faster. And now you've got twice the code to work with. Isn't that a bit of a contradiction?
Well,
in terms of being able to do things faster when you've got twice the code base to take care of.
Well, the thing is that when you are doing automated tests, there are several ways of doing that. You can do it in a traditional way and just start typing away unit tests. Or you can utilize tools such as Robot Framework and organize your tests in such a manner that you can reuse a lot of the already existing kind of test infrastructure, if you will, which means that developing tests is actually a lot faster when you have these kind of ready-made functions that you're using there.
Yeah, of course. It doesn't mean that you're going to have to manually take care of all of your test code, but still means it's exactly the same thing with your actual code that's going to production. You're going to have to still do work in order to keep that up to date. And no tool is going to do that automatically for you. You're basically doing exactly the same thing with your tests that you're doing with your code. You utilize automated tools to run all kinds of code analysis and whatever, but you're still going to be doing exactly the same thing to your tests.
Well, yeah, the fact is that you are going to be developing and running those tests. But the fact also is that if you are having automated testing, it means that you need to spend less resources on manual testing. And those resources freed from manual testing can then be applied to developing test automation. So you can hire people to make those automated tests instead of having people manually test them all the time. And the other thing here is that when is something ready? When is a feature ready? Is a feature ready when it's deployed into production, if it's not tested? If it doesn't work, is it ready? So it's kind of also a cultural shift here. Because you have to understand that when you are deploying something into production, it has to work. And the only way to ensure that it works is by testing. And it's obvious that a lot of organizations, especially where the work keeps coming from, doesn't really understand this. And this is actually something I'm going to talk about in the second presentation, which is about scaling these operations.